Morning everyone, welcome to this session. Welcome to this session number 309. And okay, today I will try to resolve this problem. Yeah, the trapping rainwater. And yeah, it's retake because yesterday I started, but well, today I will continue. And only one moment, please. Uh, uh, uh. Okay, great. Yeah, the idea with this problem is that detect how many points of water or how many squares we can fill, yeah, with water. Here, previously I showed you this problem that I think that is the key for resolve the other. In this case, for example, is a container with most water. That I think that it's necessary here because on the final we should let me check here. 49. Yeah, I think that it's very similar to this because in this case, for example, yeah, it's very similar to this because, for example, if you take this here, in the answer here is 49. This case, max area water blue. Yeah, I think that it's very similar because in this case, for example, is detect the container with most water. Yeah, and the most water is detected using the it's not a high. Yeah, in this case, use the first elements that are higher to the most. No, but in this case, okay, let me clean this. Yesterday, after finish the streaming, I was thinking that maybe in this with this exercise, it's necessary to detect this similar or have this similar logic, for detect what is the greater value. Not the greater value is more. Uh, for example, here the greater value is here, and the other is here. But do you imagine that you have this, and you have here, yeah, for example, this, and here is basically you should use this and this, and only discount all these elements. In this case, is 2, 3, 3, and is only count the size, this side, multiply for the width, yeah, less the number of elements inside them. In this case is 2, 2, 4, and 3 is 7. Yeah, do you imagine that is, I don't know, 49 less 7 is 42, and with this you can have all this calculus, right? Oh, I forget to share this problem in the, okay, it's here. Okay, ready. Now, this is my idea. Now, let me remember how I resolved this problem. Where? February. Oh my gosh, yeah. Have a few months ago that I resolved. Okay, in this case. For this monotonic stack. Okay, let me check here. We start the L, we have the right, the max is 0, and the mean it's integer max. Okay, meanwhile L it's minor to R. Okay, mean it's equal method mean between the length that we have, in this case in the left, that is 1 to right. What is the mean? Is this. What is the max? No, the max is calculus with mean multiply 4 R less 1. R is the last, in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9. Less 0 is 9, multiply 4, the mean that is 1. Okay, with this is the calculus of the how many squares with what we have here. Height it's equal mean L plus plus, when this length it's equal to the mean plus plus is and this height in the index L, that is this, is equal mean. Yeah, in this case is equal mean, this is move. Okay, now for this, okay, I think that is similar in a few points. The first that is we should I think that the first is get the how many numbers, sorry, how many squares are here. Yeah, how many black squares we have. And let me, yeah, it's equal, and one, well, it's 1, 3, 4, 5, 8, 10, 11, 30, 14. Yeah, 14. And this is important because hello. I am trying to resolve this problem. No, this no. Is this that is trapping rainwater, but it's interesting because basically it's okay. You have this barrier, so this is square in black, and you should return how many squares with water you can have in these containers. Yeah, for example, here between this and this, the max squares you can have with water is 1. In this is basically 1, 2, 3, 4. In this is 1. The answer is 6. It's calculate this. But I was checking another problem that I resolved a few months ago that is a little similar, but in this case, because this is the key, I think, for resolve the other problem. Because, for example, in this case, is contained with most water. In this problem, basically, is detect what is the container that can contain the most water possible. Yeah. In this case, for example, is this and this. Yeah. But this is more complex because in this is not the maximum, is for all, but it's very important. Don't forget that, for example, if we have, in special for this structure like T, because for example, do you imagine that you have here basically, yeah, it's possible have water in all this section. No, until here, sorry, it's until here. Yeah, and you need to calculate that. Now for calculate, I have the idea to the first my first approach is, okay, please count how many squares in black you have in total. Why? Because I have okay, I have the idea is that if I detect yeah, I think that for example here is 1. Oh, here the size is 1, the grader is 2, now here is 3, and that's it. Yeah, and with this we can note that, sorry, no, let me put here 1, 2, 3, and that's it. And now if I am here, we know that we have 1 square. Yeah, if we can move, we shouldn't count anything. If we can move another, we know that we have 2 squares plus the previous that is 1. It's equal, no. Here the first is calculate the mean value. Yeah, between 2 and 1, what is the minimum? The minimum is 1. Means that we can calculate only this. Yeah, we have 3 elements less 2, that means that the barrier is equal 1. Okay, now move to the next. We have this, but still no. No, because in this moment, how know that, okay, when you have this, let me check. Yeah, and it's more monotonic stack problem. Yeah, even if you notice, it's an increase monotonic stack, but I'm not sure here because, for example, you add the 1, you are here, move to the next, that is, okay, the first is 0. It's important mention that for example, here I don't have any barrier, but it's empty space, that is 0. But I can fill with water because we don't have a wall here. Yeah, it's the limit, but it's not part of the container. For this reason, don't appear with color blue. Okay, we are here. Put now the 0. I think that meanwhile appear the 0 is how many 0 are appearing. For example, 1, the zeros. In this moment we have 1, next to is the 2, is in increase. Yeah, I think that in this moment we should calculate this, but okay, let me continue with the next. The next is 1, should replace this. No, because if I replace these two, I lose completely this, and this is necessary for this. No, I can remove the 2. Scan left to right from 0 to max. Sorry. Could you use scan left to right from 0 to max height? Find pairs. Fill the area of zeros. Then start again. Yeah, cool, works, I think. Okay. Yeah, because let me check the constraints after continue, before continue. The n, it's the minimum is 1, and the high, the minimum is 0, maximum is this. Yeah, you are saying that we should start here. Yeah, in this, with this direction, in like this. Well, the first in this case is not count for right now, only forget this. Okay, you're saying that, for example, here fill in this way, even this. I'm not sure if it's your approach. In no, but in this case, for example, the point is that, okay, let me check again. You could use left to right from 0 to max. 6. No, because the first point is not a matrix. Here appear as a with this representation, but it's not a matrix. Yeah, you with this is basically the simulation, but I don't think that it's necessary, because basically if appear a container between 0, sorry, where the maximum is this, well, it's too much memory. I think that I can again, we have this mapping, and basically it's okay, this is 1 2 3, and this 1 2 1 2 1, yeah, and try to make the calculus between the first elements, and having all the time this logic, the max container, yeah, because it's necessary. Oh, I don't know why appear balloons here. Um, yeah, for example, if I know that the next element, for example, have it like this. The first container, it's in the index 0, 1, 3, 4, 5, 6, 7, 8, 9, 10, 11. The first container is in the index 1, the second is in the index 3, the one is 0, 1, 2 is in the index 4, and so on. And start this with this and calculus. The first is 1, the other is 3, the mean is 1, and we can use this calculus, yeah, that is mean, that is the mean of the height, in this case is 1, and next to this max basically is how many water we can contain in this container, yeah. And in this, okay, let me copy here. Okay, and have, okay, the method mean between this and this is 1. Okay, now method max, and is basically calculate this mean that all the time is 1, multiply 4 air less 1, that is 1, multiply for 1 is 1. Okay, the water that is contained between this is 2, is 1. But here I have a doubt, because for example, if I calculate between this and this is 0, and this is 1, between this and this is 0, but what happened with this and this? Now, the question, I am only checking this previous problem, but the question is how many squares or how many slots can have water in these containers. Yeah, for example, here is 1, 2, 3, 4, 5, 6, and the answer is 6. Yeah, this is the idea with this problem. Aha. Yeah, it's counting, but I'm not sure. In this case, for example, okay, it's easy. I can count. But between this and this is 0. Between this and this is 1. Okay, do you imagine that we have 2? Now it's between this and this is 0. And oh, got it. I think that, yeah, I think that we can use exactly the monotonic stack here to do this calculus. For example, okay, we have this, and we start, let me change the color, and this. We start here, and we know that this with the next barrier is basically 2 and 1. What is the minimum? The minimum is 1. The number of containers that is possible here is 1, and it's important to keep only the tracking over in increasing monotonic stack. In this case, the first time is 1, next to is replaced for the 2. No, sorry. is in, no, yeah, it's in increase order, means that 1 2 1 and 2. Now the next that is 1, this is 0, yeah, because it's not possible, the minimum is 1. Here between this and this is 1, okay, and for example the 1 is ignored, I think, because we should only keep the tracking over the elements in increased order. This one is ignored, this is 0 is ignored, this is 1 is ignored because the grader is 2. Now the next that is the 3, and here is basically the difference between this and this. Oh well, the numbers of containers we can have is basically 0, yeah, and next to is apply this operation over this, the same operation. The minimum value between 3 and 2 is equal 2, and the length of the size between this and this is 7 less 3, it's equal 4, yeah, okay, no, it's 4, multiply 4, the mean is 2, that is 8, yeah. I need, yeah, let me do again this operation here. Yeah, for example, the is 7, that is air, less this element that is the 2, it's equal 5, okay. Now 5 less 2 elements, that is the barriers, less 2, it's equal 3. Okay, now 3 is multiplied for the, no, sorry. I confused the operation, sorry. Let me do again. Is first get the minimum. Okay, the minimum here is 2, okay, got it. Now the max is between mean, that is 2, multiply 4 air, that is 7, less 3, is 4, but in this case I should, this is 8, yeah, but I need to remove 2 less 2 because are the barriers. In this case is 2, 4. Oh no. Okay, it will work because it will add 0 if the same logic, if the same height is found, so it doesn't break the logic. Okay, but here for example, let me check, because I am reducing the barriers in the wrong way. The mean is 2, it's 2 multiply 4, and here is air less 7 less this is 4, less the 2 because it's the 2 barriers, this case is 6, 2 4 6, but now we should remove the squares in black that is here between this and this, and basically is, I think that for each between the L plus 1 2 air less 1, basically here and here how many elements we have. For example, in the position 4 we have 1, in the position 5 we have no I think that it's necessary have the tracking over the water, because I can here, for example, this is counted as a new element. mm, I need the way to avoid this. uh-huh. Makes sense, because if I apply this operation before, even, do you imagine that we have currently 1 2, we have 2, and next to is calculus between this and this. Okay, we have this formula, blah blah blah, and basically, okay, you have 6 slots, and only is reduced the slot that is in black. In this case is 2, 6 less 2, and we should remove this because was count before. Yeah, in this case is 3, 1 2, oh no, yeah, it's 1 2 and 3. Yeah, we have 5, 1 2 3 4 5. Uh-huh. I think that having a map that is tracking this slot basically is counted, or this slot is marked as a um, no valid square. Yeah, but uh-huh. Yeah, and if I continue with the 2, 0 is no. Okay, do you imagine that we have the answer here? Now moving with the next, that is 2. It's not possible. The next, that is the 2, 0. Is this with this is possible? No. Between this and this is possible. Yeah, we have 1, and this and this. Okay, I think that we are in the right direction, I think. But okay, clearing a little bit this. The first point is have two maps. The first map is for map the barriers that appear here. The barrier 0, 1, 2, 3, 4, 5, 6. 7 is only 8. The first appear in the index 1, the next appear in the index in the index 3, 4, 6, 7, 8, 9, 10, and 11. And next to we should have another map with the slot that was mapping, for example, this, and this. Why I should keep the tracking of this element? Because do you imagine that if we have one container here and one container here, basically, okay, you are applying this operation over these barriers, but what happened with this? When you reach the final, you need to recalculate again all this, and basically it's okay, only remove all the elements that appear in this map, only avoid or reduce to the final answer. Yeah, Hence, okay, now obviously we have a counter that track how many elements we have. We should move in this direction, but jumping only between these elements, starting in 0 to 8. Yeah, okay, between the 0 and 1. This is our first range. Okay, what is the left barrier? The size is 1. The right barrier is 2. What is the minimum? The minimum is 1. Okay, and now is apply this operation. 1 multiply 4 r less 1 here is 1, but I need to remove the barriers here. Yeah, because here works, but between this and this it's only 2, but it should be 3. 1, 2, 3. Now this is 4. I think that is plus 1. Yeah, in this case is no. Now 1 and 2, the minimum is 1. Now the size, sorry, I was taking this value as a, no, let me remove this. Sorry, I need to use the index, not the height. Okay, this is the mean, okay, this is the height, the mean is, the max height is here 1. Okay, now is the index r less l, it's equal to, I think that here is plus 1, because for example here we have 7, I think is 4, 1, 2, 3, 4, 5. Yeah, I think that is plus 1. Plus 1, this cancel it. And less 2, that is the barriers. It's equal 1. And this is multiplied for this. We have 1. And is mapping in the index. No. In the index 0, 1. In the index 2, we have 1. Okay, let me continue. Now we have this calculus, and we have our monotonic stack with 1, 3. Now okay, we have this calculus now is between this and the next, or in other words, is the one is okay. Now is between 1 and 2. Okay, in between 1 and 2 is basically this. Is 4 less 3, it's equal 4 and 3. No. Is what is the minimum between 4 what is the minimum between the 4 and 3? It's equal, the minimum is 3. Now is the operation that 3 multiply 4 index 4. Again, I am taking the I am confusing the value, sorry. Mean is between the size. In this case, the first size is 2. The mean between 2 and 1, it's equal 1, okay? Now it's apply the operation of the R less L is 4 less 3 plus 1 less 2. 4 and 3 is 1 plus 1 is 2 less 2, it's equal 0, and is 1 plus 0, it's 0, okay? And now we have this check. Now it's between 2 and 3. 2 and 3. The 2 is in the index 4, that is this, and this. Basically it's here and here. Here and here, okay? The first is get the mean height. In this case is mean between 1 and 1, it's equal 1, yeah? Now is calculus the how many squares are between this. In this case is 6 and 4. 6 less 4 plus 1 less 2. This is 2 plus 1 is 3 less 2 is 1. Yeah, is here and is mapping here. Yeah, we have this is a counter. We have 2 and now it's mapping here. The square that was count is this is the index. Now here the index is 5 and it's 1. Yeah. Now okay, this is done. Makes sense this approach. I'm not sure, because usually these kind of problems you discover at the final, oh my gosh, I was in the wrong way. But until now, for me, makes sense. But well, okay, now this check. Now the next that is the between 3 and 4. The 3 is in the index 6. Between this and this, yeah, this is our current pair. Well, I use Java for algorithms. I use Java. I would like to use Python, but well, currently I am focused on the algorithms only algorithms. Maybe in the future I will change to Python, but currently I'm using Java. Well, now we have this is our pair, and basically is okay, first calculate the mean. The mean is between 1 is the height, the mean height, yeah, and the next is 1 2 3. My gosh, here the mean is 1. Next to is the calculate is R less L plus 1 less 2. This is the formula. Is 7 less 6 plus 1 less 2, and this is 1 plus 1 plus 1 is 2 less 2, it's equal 0. Makes sense because don't have anything. Is 0 plus 1 is 0, and okay, don't have elements. But here why I have here this is 2, and now x is 3, yeah, that is here. And okay, this check. Now the next is between 4 and 5. Okay, 4 and 5. That is this and this. This is our current pair. The mean is 1, 2, 3 and 2. Okay, the mean is 2, and here is basically is 8 less 7 plus 1 less 2, it's equal. Here is the result of this is 1 plus 1 is 2 less 2 it's 0. Makes sense. And it's check. Okay, don't save anything, and still having the tree as a greater value or the maximum height. And okay, now the next is this. This, yeah. And well, we know that the result is 0, yeah, because are don't have a space between them, are continuous. Yeah, even when it's continuous, the pairs is only a void operation because don't make sense. For example, this don't make sense that use the array. It's only if this and this are continue, ignore. Yeah. Now this is 0. Okay. Check. But in this case, for example, when it's 0, okay, let me continue. This 0, 0, 0, okay. And the final is only you have 2, yeah, in the first iteration. Next 2 is apply this operation over no, I think that at the same time that I am calculus this, for example, these squares will appear between two barriers. We should apply this operation. Yeah, because for example, if we are in this pair, okay, the result is 0, whatever. Now the next that is this, the result is 0. Now the next is this, but in this moment is ignore this. You notice that it's ignored. I need to in which way I can calculate this. If I complete this, basically the highest barrier is 3 and the mean is 2. Sorry, is 1. Is apply this operation over this. But what happened with this square or this slot? I feel that we should do this operation, but in which way? Because here makes sense that use this monotonic stack in increase order. I can calculate this, but what happened with this when it's in decrease? I should have another monotonic stack for the decrease in the decrease order. We don't have any hint. Yeah, how can I calculate this square? I have doubt with this, and especially with this, because if I am using the increase monotonic stack in increase order, basically the tree is the higher, and next to all the next element are ignored. Oh yeah, I think that if let me delete this. Keep this tracking over this element, but when appear, uh-huh, yeah, I think for example here, where is yeah, here we are here, yeah, and the calculus between this and this, let me forget. Okay, the calculus between this and this is 0, okay, because are together. Now, uh-huh, now is between this and this is 0, because it's basically this, and is 0, but it's take this with the maximum. mm, no, uh, 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 uh. I don't have more idea. um, yeah, the situation is here is when, let me check what happened if I have a decrease monotonic stack. The minimum is 1. No, no, I think that in the decrease order doesn't work. Mm, uh, 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 uh. Okay, let me put 10 minutes. In if 10 minutes I don't have more ideas, I will check the answer. Um, yeah, the situation is here because are together, and is 0, 0, 0. But here appeared this. Um, ta, 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 ta. I know that I don't keep in silence more in interviews, but oh my gosh, in this kind of problem, it's very hard to think and speak at the same time. Um, well, let me check. Currently, we have this problem. How calculate this? Yeah, and this can calculate with the max, that is this, and the mean, that is this. Oh yeah, yeah. I think that, yeah, because for example, here, okay, the calculus. The first point is when the barriers are separate at least for one square, you can apply the operation of this basically. Yeah, when are together, yeah, like this, we should use the max that is 2. I think that I need to apply two calculus. The first calculus is between the barrier, the pair basically. Yeah, in this case this is a pair, this is another pair, this is another, another. Yeah, this is the first calculus, and the other calculus is between the right, no, yeah, the right barrier, for example, here, and the maximum to the stack that is here. In this case, for example, is 1. The minimum is 1, and we should apply this operation here. 10 less 7 plus 1 less 2, and here is 3, 4 is 2. 3 plus 1 is 4, less 2, it's equal to 1 and 2, okay? But we should reduce the elements that appear in this map. For example, between the 7 and 10, apply a for each and validate. The 8 appear here. Is the 8? No. Yeah, is the, no, is the index. I need to know how many squares are black here. That is 7, 0, 1, 2, 3, 4, 5, 6, 7 here. No, it's here. 2. Okay, in the index 8 are 2. In the index 9 I 1. No, even I can avoid this operation and only okay, we are focused in this case, yeah, for example, and we are here. Okay, this is our pair, current pair, 9 and 10. Okay, the result is 0, that's it. And now is the right side versus the max or the peak element in the stack, that is 3, yeah, because it's the higher. And in this case, basically apply a for each over this element between 7, oh my gosh, between 7 to 10, yeah, and it's only but here the max is the difference between this and this is 1. Okay, the max size is 1. No, sorry, the max size is 2. No, sorry, the mean of the this is 2 because it's basically this height. And next to is count between this, and discount the elements that appear. For example, in the 7, is the max is 3, but appear here, and we need to remove. Okay, when the element is higher or is greater than 2, only keeping 2, and is basically this is transformed 2, and is okay. We have 2. Now to the next is this, that is 2. The next that is 1, and the next that is 2, and this is 2, 4, 5, 7. And if we want to calculate this, is basically 2, 4, 5, 2468 8 less this value, it's equal 1. Yeah, and in this way, for example, do you imagine that our barrier is in of the t size 3 and 3? We can get this, basically this t or this form, yeah, because it's only get the total number, like, I don't have the problem, but it's have the total less the this square in black and less that the squares that can be counted before. For example, in this case, this was counted before that appeared here. If appear here, it's only remove it. Yeah. Yeah, I think that could works. In okay. Point number 1, we need an stack in increase or monotonic stack in increase order. We need an map for mapping the pairs, that is this. Another map for mapping the squares with water that was or has been marked, for example this and this. And the last point is we need always calculate the right side with the maximum element in the monotonic stack. Makes sense? I'm not sure if I explain clear, but well, let me try to codify. I'll try to do this code. Okay, I need an stack. This stack is integer. Okay, integer stack, it's equal new stack. Yeah, this is a stack. Then another is a hash map. This hash map, it's an integer, and integer map, it's equal new hash map. Yeah, let me track the max height. Track the pairs of the pairs, yeah. And the other is similar like this, but the difference is that this, let me change this, pairs and map. This track the pairs and track the slots has been checked before. Yeah, for example, this and this. No, but I'm thinking in this case, for example, and this, okay, is one is marked, okay. Now it's between this and this, no, and the greater is this. Now between this and this, Okay, we have this element, and this is with this is calculus, and it's basically this, but it's ignored because has been marked. Now it's between this, well, basically this is 0, but between this and this is 2. How I mark this element? I need move this element here. Yeah, because I counted, but never in any moment. Yeah, I need save here, but okay, we have the 2 and 3. The mean is 2, and is between the index 7 and 3 is for each this element, and is count. Yeah. Uh, no, I think that this is a problem because in any moment is marked as a is market that is contained water. Do you imagine that you have here one wall here and one here? Basically, when you reach this side, you well, I will try to calculate the total, rest this and this and this and this and this, but this is counted again. Mm. Uh, okay. Um, I will check the answer because I I passed the 10 minutes that I had. I don't like the idea to apply a for to create these elements because basically it's the simulation. And here is only one, but you imagine that you have like this. You need basically it's a matrix version. Mm, no, I will check the first the comments. uh, 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 uh. But I think that I think we are in the right way, but what happens if I ignore the operation over the monotonic stack? This and this. No, but in this case, what happened with this? No, I sort of no. Okay, I will check the brute force. Dynamic programming, not yet, because I don't reach this topic using a stack, using 2 pointers. Okay, the stack. Oh my gosh, the solution is very simple. Let me check. Add the queue. Let me copy this. What is the... Okay, we have answer and current. We have add the queue. Meanwhile, current it's minor to height of well, basically is for each bit or transversal all the elements, while stack is empty, and well, it's monotonic stack basically here, and the height in the current is greater than the previous. Okay, it's an increased monotonic stack, yeah, because if the current, for example, this is greater than this, is removed. No, it's take the element, is removed. This is exactly the same like this. Current and stack peak less 1. Current that, for example, is this. But what is current? Current is the index. The index is, for example, okay, we start here, it's empty, only add the 1. Yeah. I think that is much better. Only paste here and here. Okay. Yeah, but here, for example, use the DQ. For resolve, okay, because the first answer is current 0, okay, create the DQ. Now it's if current, that is the index, is basically this is a 4 over the elements, okay. Next to is while, okay, the first is empty, yeah, it's empty, only push the in the stack, the index, no, it's not, yeah, it's 0, yeah, the index 0, because it's turning current, and and increasing 1, now this 1, next to, okay, move to this, now we are here, stack is empty, no, okay, and the height of the current, that is 1, is greater than the peak, that this, yeah, in this case, top, it's equal this, that's 0, and it's remove it. Next to is empty, yeah, it's empty, break, and okay, break this and only push the 1, okay, move with this. Now the stack is empty, no, the current height, that is 0, is greater, no, okay, it's only add here the 2. Yeah, I know, but this is the solution that propose here the lead code. Oh my gosh, this is more clear. But well, let me check first this solution because I was using this approach. Okay, now stack.push current that is 2, 0, 1, 2. Okay, next 2 is moved here. Now the current height is 2 and the top here, what? Sorry, is the, yeah, yeah, basically here is the index. Let me come back. And I need copy the, come on. Okay, now the first time is 0. Current is minor to the height. Current is basically the index, or the index. While empty is empty. Stack is empty. In this case, it's ignore this and it's only push 0. Yeah. Okay, now move to the next. Now we are here. The stack is not empty. Okay, and the height in the index here is greater than the previous. Yeah, in this case this is removed. Top it's equal 0 and stack is empty. Yeah, only break this and add the current that is 1. Okay, now move with the next. The next is this. Stack is not empty. The height in the current that is 0 is greater than this. No, only add the index 0, 1, 2. Now the next is stack contain element, yeah, and the height in the current position that we are here, that is 2, is greater than the previous, that is 1. Yeah, we need to remove this. Top it's equal to, this is removed. And stack is empty, no, because it's still with the number 1. The distance between current, that is here, that is 0, 1, 2, 3, less peak less 1, this is 2, this is 1. Okay, say that is 1. Okay, now let's calculate this. It's equal mat.min height in the current, that is this, or height in the peak, that is 1, less top, that it was 0, is 1, less 0 is 1. What is the mean? 1 or 2 is 1. Okay, this is equal 1, and answer it's equal the distance, that the distance was 1. multiply 4 1 is equal 1. Oh my gosh, it's very complex operation, but and move on. Yeah, basically this resolved the problem that I had. The distance. Okay, now let me check very fast the solution that using two pointers. Uh, oh. Okay. A while. Answer. The answer. Left max. It's minor. Oh my gosh, it's only. It's only count. Yeah, it's very similar to the other problem. What is the. Similar question. Containment. Like this. Yeah, was very similar like this. Well, I need to study at this problem for more time because yeah, I I I will follow this approach using the two pointers because with the stack is very crazy. Yeah. Okay. Thanks for watching this transmission.